Okay, I think we can start. Welcome back, everyone. We're midway through midterms week. I hope it's not been too intense for you. For this class, we're again not doing anything too exciting for midterms, just reporting the grade that you have here in the Canvas system once we get to Friday. But what is exciting is we're starting out a brand new chapter on statistical reasoning. We briefly just broke into Unit 5A to just talk about the first set of definitions. And it's a pretty big change of pace. In Unit 4D, really all of Chapter 4, it was highly computational. Now, for statistics, so far, both of these units really just about concepts, getting used to the vocabulary before we start beginning to look at some of the computations in Unit 5C. So there's lots to talk about before we even get started: population, sample, and parameter versus statistic, and other things about sampling designs and so on that we're going to be getting into in this unit. Well, that's pretty much all I have for announcements. Quiz 6 is based off, I believe, let me double check. Yeah, Unit 4B. And Quiz 7 is going to be based on Unit 4D we have down here. Any questions at all, folks, then, about the announcements or anything else before we get started? Okay, let's jump in then. So here's where we are in Chapter 5, Statistical Reasoning. Again, we only just started out, and we read through the definitions, but the thing that's tough about all of these definitions is it's really hard to really get a feel for what this is saying when it says the population in a statistical study is the complete set of people or things being studied, and so on with the other four definitions. Well, four in total here. It's hard to say what are these definitions trying to say unless you anchor it into an example. So that's what we were doing when we were ending class on Wednesday, writing in quick examples that could stand in for a population, a sample, a parameter, and a statistic. So let's go through those again. And example one down below is really just doing it all over again with different kinds of contexts. So for a population that we were imagining, we said all ISU students registered for spring 2026. It's a big, large, unwieldy population. So to study it, we were imagining we had a sample. By sample, we mean a literal subset. So everyone inside the sample has to be an ISU student, but we're not trying to study the entire population any longer. Our sample was at size 50. It could have been a size 1,000 or maybe even small at size 15 students. But we said take 50 ISU students registered for spring 2026, and that was our whole sample. What's below is indicating what the study was about. We were asking everyone in the sample how many ounces of water they drink in a typical day. Then once we ask that, we have effectively said what the parameter is and the statistic is going to be. The parameter is some number that describes the entire population of all ISU students. And for this simple example, the parameter is going to be the mean, or you could just say average, number of ounces of water per day among every ISU student registered for spring 2026. So if that's the unknown value, parameters are typically unknown quantities describing the population. But if we had a sample of 50 students and we got a value for the amount of water they drink in a typical day, that's something we can calculate. We'll just add up all the observations, divide by 50. We often will say mean, but we mean average, number of ounces of water per day among all 50 students in the sample. And this is the known value. We take this known value and we say it approximates the unknown, the population parameter. So that's the rundown with the definition so far. Any questions or comments about population sample or parameter versus statistic? Okay, well, to get a feel for how these go, here's what a typical question is going to look like. They're not as tricky as they are on paper, it turns out, because when you do these in MyLab, it's multiple choice. So you have a really good idea of what the thing, the parameter or population might be. Writing it down on paper, that's the extra challenge. So we'll take some time breaking these down. In example one, it says, in order to assess local interest in building a new community recreation center, a city planning committee mailed a questionnaire to 850 city residents, asked them to rate their support for the project on a scale 1 through 10. 1 is going to represent no support, and 10 will represent full support for building that new community center. So let's see if I can get a quick screenshot here. Maybe just to this level. First thing we want to describe is what is going to be the population, and what is going to be the sample. The idea with the population is it's everything or every item taken all together. Anyone see what the population should be in this problem?
All city residents.
Yeah, absolutely. And I think a good hint on this one is actually thinking in terms of the sample first. Because when they said that they sampled or they mailed a questionnaire to 850 city residents, that sounds like they're talking about the sample right there. And so that would mean, just like you said, the population should be all city residents. We want to assess everybody's opinion on building the new community center, how much support they're going to have. But if this is a really big city, maybe something like, say, San Fernando, a place with millions of people, this could be really hard to assess. So I don't know if this was the best sampling design, but what they are doing is they're going to mail a questionnaire to 850 city residents. That'll be the sample. So we're going to say the sample is the 850 city residents selected. So that's our first walk through the definitions. The population is everybody. So when you do this as a multiple choice type of question and say in my lab, watch for keywords like all. Sometimes that's the only thing that makes a difference between a right answer and a incorrect answer. Here, for the sample, usually they're going to tell you the size of the sample that's selected in a typical problem, and it has to come from the underlying population. So if we said 850 residents from some other city, then that would be an incorrect choice in a multiple choice problem. Well, now that we're done with part A and part B, one thing that we might be thinking about already is this is the sample, but this study might be kind of doomed because if you just mail people a questionnaire, I think a lot of people these days in 2026 are going to see that as junk mail. They're just going to tear it up and not respond. So there might be some big problems with this entire design in the study. But if everything went perfect, if everyone responds to this, they actually filled out their questionnaire, mailed it back, hopefully prepaid postage, that really would be the sample. Next thing we need to take a look into is parameter versus statistic when we're thinking about this study. Whether it's doomed or not, we can still answer the relevant questions about it, thinking about the definitions. And when we say population, we meant all city residents. And when we say population parameter, we're talking about some specific number that's relevant to this study. It's going to be an unknown quantity, more likely than not. So when we write it out, it involves a population, all city residents, but it's also going to involve something like the mean, or you could say average, of something. Let's reread the context once again. Sometimes in a statistical problem, just reading this several times is a great strategy. Read it once to get the lay of the land on the problem. Read it again just to refresh what it's all about. Then when you finish the problem, probably reading it again just to make sure your answers really make sense is a good idea. So the population is all city residents. The sample is the 850 selected for the study. And they were asked, these 850, to rate their support for the project on a scale of 1 to 10. Well, thinking in terms of what we were doing here, we're going to ask all students in the sample how many ounces of water they drink in a typical day. That implied what the parameter was, the mean number of ounces of water per day among all ISU students. And same idea here. Everyone in the sample of 850 residents is just going to report a number 1 through 10. But that means the population parameter is going to be the, let's say, either mean, or you could say average once again. I'll say the mean rating score for support of the community center among all city residents. So we have the population built in, and not every single city resident is going to do this questionnaire, just the 850 in the sample. But what we're imagining is if every single person in the population had the opportunity to rate their support of the new community center on a scale from 1 to 10, we can then ask ourselves, what would that average be? That's the unknown parameter. Everyone's true opinion on average, or the mean rating score. Well, does that make sense to folks on what the parameter would be in this problem? Okay, these problems, again, tend to be kind of abstract. So sometimes it takes a moment to kind of wrap our head around what are we saying when we say parameter versus what are we saying when we say statistic. So let's now turn over to the statistic side. A sample statistic is really this whole thing that we just said, except that we're talking about just the people inside the sample, which was the 850 city residents. So when we go to describe the sample statistic, let's maybe put this on a new page. Maybe in a moment, so we can see it all with the definition so far. When we go to describe the sample statistic, we're going to say this is the average or the mean rating score for support of the community center among the 850 city residents. And let's just say, just to be specific, the 850 city residents in the sample. So that's what our statistic would be in this context here. So your parameter has to describe the population, all city residents. The statistic only describes the sample. So we said just among the 850 city residents. And to really hammer in we meant sample, we said it here in ordinary words. Well, any questions, folks? Getting through example 1? Okay, well, let's try this out all over again. I have really 2 more examples. Example 3 is kind of a different format, a larger example. Example 2 is very similar to what we just did. This one is a different kind of study. It says, in a test of the effectiveness of garlic for lowering cholesterol, 47 adult subjects with high cholesterol were treated with garlic in a processed tablet form. That sounds like that would give you a really weird aftertaste. Cholesterol levels were measured before and after the treatment. And we don't know how long this was going on. It might have been, say, they were taking this garlic tablet for 8 weeks or something along those lines, the average reduction of the subject's cholesterol level was 3.2 milligrams per deciliter. So before the study was even conducted, they knew their cholesterol level on average. Then they had these 47 adult subjects take the pressed garlic tablet for, let's say, a period of time, probably 8 weeks or maybe slightly longer. They measured the cholesterol level again, and they found it went down. There's an average reduction of that amount. So that's the context so far. Not too different from example one, but this looks like it's a study that's going to succeed, because a study based on mailing a questionnaire back to get answers for your data, this looks like it's going to have a particular kind of bias where people just may not even read that questionnaire whatsoever. However, here, this sounds like it were people that actually walked into a facility. There were people that were selected. They possibly were paid to participate in the study, and they actually have the data on everybody more likely than not, unless something happened. Maybe it originally was 50, but 3 people had some kind of thing happen. Maybe it left the entire country, who knows? Well, again, the population and the sample are not always easy to identify, but here's a big trick about thinking about both of them at the same time. The sample absolutely came from the population. And when they start talking about a number of subjects, that's a great keyword here right already. They're talking about the sample. So when it says 47 adult subjects with high cholesterol were treated, I'll stop right here. Let's highlight this. To me, that looks like the sample. And sometimes, even though the order is different, that might be the easiest thing to spot in the problem. So if you do these kind of questions, say out of order, it's a decent strategy. Let's say here, the sample is 47 adults. We have to say a little bit more because the study isn't about any adults taking a garlic tablet. This reduction isn't relevant to everybody. These are people who specifically had high cholesterol, however the study defined that. So we need to say for a sample, 47 adults with high cholesterol selected for the study. Now, once you have the sample written down, it came directly from the population, and this is all you have to say for the population now. The population is not the 47 adults. We're talking about everybody now. So this will be all adults with high cholesterol. That's a pretty broad population. So realistically, if this was a real study, it could have been something along the lines of all adults in a particular region, maybe all USA adults, or maybe this was a study specifically done in somewhere like Germany. Maybe they're talking about all German citizen adults and so on. But from the context that they gave us, this is a very broad population, but we threw in everything we knew about it, and there we have it. All adults with high cholesterol. We mean globally now. Any questions at all, folks, with the population versus sample on this one? Okay, so we know what the population is. We know the sample is 47 people selected from the population, just meaning they're adults with high cholesterol. But then they did something to these people. They were treated with garlic in pressed tablet form. So that's an interesting treatment. They also made some measurements. Cholesterol levels were measured before and after the treatment. And we happen to know the average reduction in the subjects was 3.2 milligrams per deciliter. Echo says, should we say all adults when it's actually a small sampling of adults? Well, the small sampling of adults would be the 47 adults right here. But when we talk about population, what we're really meaning is let's pull up that definition. We mean the complete set of all people that meet that condition having high cholesterol, or if we're looking into a sample of, say, animals or objects of some kind, we'd say all things. So anytime we're thinking about the population, we mean everybody all at once. So if a population is ISU students, we're talking about all ISU students versus a small sample of size 50 here. And similarly, in this context, if we're talking about, say, the 47 adults in the sample with high cholesterol selected for a study, it implies population must then be everybody that meets that criteria having high cholesterol, and they're also adults at the same time. Thanks for that question. Does that make sense on why we said all here, but 47 below? Awesome. Other questions at the moment? Okay. Now, next thing we want to do, similar to the last question, is come up with a population parameter, some number that describes the entire population, come up with a sample statistic, some number that describes just the sample of 47 adults. We're describing it. So in the last problem, we didn't actually have the number for either one. We don't expect to get a number for a parameter in a real statistical study, but this one did give us an average. So this is one known value that we can put down here, but we still have to describe it and we still have to use the context. Sometimes putting in the context is the extra challenge when it comes into statistics. Any volunteers for what either value should be, either the parameters or the sample, described just with ordinary words using context?
The parameter would be the mean effectiveness of the garlic for lowering cholesterol among all adults with high cholesterol.
Yeah, exactly. That's a great way to specify this parameter. So we'll say the mean effectiveness and by effectiveness, we mean reducing cholesterol. So mean effectiveness of cholesterol reduction. And again, this is talking about the population. So we have to loop back into what was the population in the very first place. So we'll say among all adults with high cholesterol. So we have the population there, and we did something to this population. We also are imagining at the same time treated with garlic in pressed tablet form. I'll just say given the garlic treatment. So we can't imagine that you could actually globally find every adult with high cholesterol and give them this treatment for however long it went, maybe 8 weeks, order them to take the garlic in pressed tablet form. So this is kind of a hypothetical value in the very first place. It's certainly an unknown one, yet we still want to estimate it. We're still going to imagine if we could get everybody on the planet with high cholesterol, that's a population, to take the garlic treatment, then we wonder what then would be the average effectiveness in reducing the cholesterol. So that's an absolute unknown in this problem. However, even though it's unknown, it can be approximated. We can give a margin of error to that approximation, and the study informs us how to do it. We have a sample here, 47 adults, 47 adult subjects, and the average reduction in the subjects is given 3.2 milligrams per deciliter. So this problem is slightly different than the last one. We know the statistic, it's right there. So we can say, we still have to describe it and use the context, but we can write out this. 3.2 milligrams per deciliter is going to be equal to the mean Notice we're pretty much going to copy this same language that we put down here for the parameter, but what we're changing is we're not saying all adults, because we're talking about the sample now. We have to talk about just the 47 people that actually did take the treatment. So 3.2 rather milligrams per deciliter is the mean effectiveness of cholesterol reduction among all, excuse me, not all, among the 47 adult subjects. And we don't mean just any 47 adult subjects. We mean specifically the ones in the sample that they did something with, that were given the garlic treatment, that were given the garlic treatment. You know, I want to put in one additional word. I did say 47 adult subjects in the sample, but I just want to be extra precise and say with high cholesterol. So let me, backtrack a little bit. That had high cholesterol and were given the garlic treatment. So we did it, folks. These are, in my opinion, pretty tricky problems to run through. It's the complete opposite of what we did in just the last unit, Unit 4D, and finding the monthly payment amount. That one was almost pure computation. And these problems are almost pure context, thinking about what's going on in the study in terms of technical definitions and the context provided. Any questions or comments at all, folks, getting through these? Okay, one other statement is sometimes it's easy to get lost in what we are saying when we write out the word mean. And by mean, that's going to be considered fully synonymous with just the ordinary word average. Like talking about the average cost or the average height or the average distance and so on. Well, that's two pretty different sets of contexts. One study that looked like it's probably doomed but the moment they thought it up. This study looks like it was pretty successful. And we have a known value right here. We know the sample statistic. And even though this one's unknown, we can now estimate by saying, we believe now, if this study was done appropriately, if they got the sample in the right way, and we'll talk about sampling designs and randomization, if they did everything right in the study, then we can say, we believe that this parameter right here is approximately 3.2. So if everyone on the planet with high cholesterol is what this is saying, it's a broad population, were to do this pressed garlic treatment for 8 weeks, if that was the time they took it, we believe that they'll have a 3.2 milligrams per deciliter reduction of cholesterol on average. I'm not a doctor, that seems kind of small, but hey, it looks like there is an effect that's going on there. There's more to that story, and that's what example 3 is going to be all about. So let's turn into the next example. It's the basic steps in a statistical study. So lots to kind of digest, but we're thinking about all along when we were looking at these really last 3 studies, thinking about the first one with the population being ISU students. And also I have a graphic here that I just purely stole from the book. This one is pretty good. So I teach other statistics classes. I might actually cite this table or this image right here in a different class. So it says, for the basic steps in designing, running through, and making conclusions on a statistical study, here's 5 basic steps and an overall flow chart that are great to think about. It says, state your goal of the study. What is the purpose of the study? What are you trying to test, what are you trying to measure, is this part right here. So that's step one, identifying the goals. Once you've identified the goals, the steps here and the flow chart seem to be slightly in conflict. It says choose a representative sample from the population, but that means you've already identified the population. That's kind of a step two, really, maybe a step 1.5 before getting into step two. Typically, the population is pretty hard to study, but maybe if it is something along the lines of a very, very small population, maybe a rare disease of which there's only like 12 known cases globally, something like that. Or maybe your population just happens to be all students in a class of which there's 22 like this. If you can measure everyone in the population, you actually don't have to do statistics in a normal way. You would just calculate the parameter. You would know what this value is. So you never had to worry about computing a statistic. You get the exact value of the parameter. But those situations are kind of rare in actual practice. In actual practices, populations are large. They could be all birds of a particular species. They could be all certain kind of fish in the entire Atlantic Ocean. It could be all students at ISU, and that's still a really tough population to study. Because of that, we choose a representative sample. We're going to have to say exactly what we mean by representative, so there'll be plenty of discussion there. But we can think in terms of representative. Best way to get it is to take some form of random sample, use randomization. That takes us to this block. Once we have the sample, we can now compute something. We can get a value. We gather the raw data, whatever we're measuring, if it's cholesterol reduction or level of support for a community center, like on example 2. Once we have the sample, we'll collect the raw data, summarize by computing averages or computing percentages if we need to, depending on the type of data. That'll be step 3, producing the sample statistics after we summarize the data. But once we have the sample statistics, the sample wasn't the whole point. The whole point was studying the underlying population itself. And that's where we do statistical inference. We take the statistic and say that statistic approximates the population parameter itself. So once we make an approximation here, notice it kind of flows back to the population. We make some big overall conclusion about the population itself. So that's exactly what was going on in examples 1 and 2. Example 2 just happened to have a value for the statistic. I feel like it'd be a good idea to just look at this whole flow chart in a new context, example 3. And this one is a real study, it turns out, published in the LA Daily News back in 2016. Before we take a look into that example 3 context, any questions about the basic steps or the flow chart here? Okay, this problem is kind of unwieldy. It's really 5 different parts. Describe the basic steps in a statistical study for this situation. I felt like it didn't make a very good problem in my lab. It was just kind of too unwieldy with lots of parts, lots of opportunities to make just a simple mistake and have to start it all over again. Those are frustrating problems. But still, I felt like it's a good problem just for the sake of notes to think about population sample, statistic, and parameter once again. So it's not going to be a good homework problem, which means example 3 is probably not a good exam problem again as well, I mean. So think of the reason we're doing example 3 is just to reinforce all 4 of these definitions we see here. So let's look into the study. It said, San Fernando Valley residents okay with a 1-cent transit tax, an MTA poll says. So that's the entire statement right here, which was the headline of an article that appeared in the LA Daily News in 2016. And I actually did not know this part. I've actually used this problem before in other statistics classes, and I learned this semester a transit tax is not a tax on driving on a highway or anything. That's a sales tax. Transit meaning a transaction of money for goods is what's meant there. So I only just learned this right here. That's one thing that's tricky about context is you can read it one time or dozens of times and still miss something. A 1 cent transit tax is referring to increasing the local sales tax by 1%. And that could be a lot, right? If sales tax in Idaho is already 6%, going up to 7% is something I think a lot of people would probably feel and not be happy with. So it was a shocking title that the San Fernando Valley residents are okay with the 1 cent transit 1 cent transit tax, or 1% sales tax is what it's really saying. This is now says just more information about the study. It was based on responses from a representative sample. They didn't tell us how they got it, but we can possibly read this report here if we really want to know more. There's a representative sample of 100 San Fernando Valley residents. And they tell us even more. Of the 100 residents in the sample, 52 were in favor of the 1 cent transit tax. So that's not an overwhelming amount, but it's more than 50%. So the article just said they're okay with it because it's more than 50%. We're going to have a lot to say about that. But first, we want to describe the basic steps in the statistical study, really just thinking about population, sample, statistic, and parameter once again in this order, in the new lens of steps 1 through 5 that we see here. Any questions at all, folks, before we give this a try? Okay, let's write these down, just kind of going in order of the flow chart and the steps we see, paying particular attention to population and sample. So step 1 is to identify goals. And if we see a study like this, the implied goal is probably just to assess support for the 1% sales tax. So that's probably what I would say for identifying the goals. The local government is assessing support for a 1% sales tax. So that's the whole goal of the study. To do that, they had to say, who is the study really about? They have to address the population right away. So let's put down the population on paper, even though it's not a step in the process, not paper, population. It's not a step in the process, but it's very important. It links the steps together. Any volunteers at all to say what the population would be in this problem?
All the San Fernando Valley residents.
Yeah, absolutely. The sample was just 100 of them, so that implies immediately, just as you said, all San Fernando Valley residents. So once we have that population in mind, we sample from that population. Again, hopefully doing some kind of strategy using randomization. And there'd be various ways that that could be done. There's probably records at the DMV. There's probably records for state taxes at the government level and so on. They can take a random sample of the San Fernando Valley residents. What they don't want to do is say, go to just any one spot, say a local Walmart somewhere in San Fernando Valley, and just ask 100 people that show up at that one spot what their opinion is. That's going to be biased and it's not going to be representative of San Fernando Valley. That's a gigantic place. So we have to take a lot of care on how they get that sample. And they did say we would have to assess if we really believe this, but they do claim they have a representative sample of 100 San Fernando Valley residents. So that's step 2. And step 2, the sample is 100 San Fernando Valley residents. It came directly from the population to the sample. The error is going to be annoying to leave it on paper, but that's the idea. We pulled specifically from there. Once we got the sample, they asked everyone in the sample if they were in support with the 1 cent transit tax. Hopefully they said 1% sales tax really, because that might have confused people. I know it confused me on what the exact meaning was for a transit tax. And they found 52 were in favor amongst the 100. But that's the step 3, collect the raw data and summarize. When we do that, we come up with a sample statistic. So from step 1, we are now going into step 3. We can say, for collecting and summarizing the data, 52 are in support out of 100 in the sample. We can convert that to a percentage if we would like, go times 100%. And we have now 52% in support of 1% sales tax. So that's collecting the raw data and summarizing. We've just produced a statistic doing the raw data collection and summarizing it in this kind of way. So this is now the statistic. Let me see if I can just zoom out just a touch. Let's just maybe write it out this way. 52% is the statistic. So once we have the sample statistic, we want to turn that over and go back to the population. We want to infer something about the entire population of all San Fernando Valley residents. And the inference we'll make at this step is approximately 52% of everybody is in support. At that point, we're talking about the population parameter, which is an absolute unknown. So let's write this down on paper here. This is step 4. The parameter is going to be equal to percent of, once again, I'll capitalize it for emphasis, all San Fernando Valley residents in support of the 1% sales tax. So we have a parameter, and what we're about to do, if this feels weird to you, it should. This is almost a little bit unfair. We're saying, let me just scroll down just a little bit. There we go. We're saying 52%, which described just the sample, is an approximation of the population parameter itself. So we're going to say this parameter is approximately 52%. There's some real trouble with that, but let's put it down on paper regardless. And that's the trouble that's coming up with this study. The study wasn't 100% honest the way it was stated. It's a bit troubling what they said. Just trying to get a little bit more space. There we go. So we'll say here, the parameter is approximately equal to 52%. And that finally takes us to step 5. We draw a conclusion, and that's exactly what the article in LA Daily News did. That's their conclusion. The residents are okay with the sales tax. They mean majority of residents, but even if they put in that qualifying statement, the majority of the residents, more than 50%, are in favor of the sales tax, it's still problematic. But let's go with what the article said, draw the conclusion about the population. Let me scroll down. Finally, we've got to get some more space going this way. Step 5 in this whole process is we conclude a majority of all San Fernando Valley residents are in favor of the 1% sales tax. So that's our drawing conclusions, but it is a very worrying conclusion. Well, any questions at all, folks, about the steps so far? Or any comments on what makes this conclusion kind of a troubling one to make? Okay, in my view,
Oh,
even if
sorry,
we
I was
say,
gonna ask if the conclusion could also be conclude that over half of all San Fernando Valley residents are in favor.
yeah, absolutely, you could put in place of majority here. I like that better because it's way more specific. Instead of saying majority, which doesn't feel like we're putting down a number specifically, we can say conclude more than half of all San Fernando Valley residents in favor of the sales tax. Yeah, I like that a little bit better than just saying majority because this is very precise. We have an exact number we're talking about. Majority implies 50%, but this is actually saying it very, very directly. Other questions or comments at the moment? Okay, here's the problem with this conclusion. No matter how we write it, this one's obviously really bad. I think they're just trying to sell more papers at the LA Daily News because it's shocking that San Fernando Valley residents are okay with a 1% sales tax. We're okay with being taxed more is a rare public opinion in my view. Even if we make it more than half of all San Fernando Valley residents are in favor of the sales tax, it's a little bit better, but it still has one massive problem. We estimated, we're talking about the parameter, which is all San Fernando Valley residents percent support. But the moment you estimate, even if you do everything right and you got a random sample that represents everybody, no errors in computing the data, you got the right statistic, that's an estimate. And that estimate is really useless actually until you say what is the margin of error in making that estimate in the very first place. How reliable is it? What is its accuracy? Or in other terms, what is the margin of error? The margin of error could be large. The sample is actually not that big in terms of controlling the margin of error. This could be an error in terms of as much as 10%. So the parameter could be as high as 62% in support or as low as 42% in support, well less than half. And so let's put just one quick statement here. The estimate is, this is a bold word, but it's true that it's useless until we find the margin of error in this approximation where the red box is. That deserves an exclamation mark. And we're picking on LA Daily News a little bit, but it's an easy mistake to make, right? If you get a statistic, we're saying it's approximating a parameter, which means we're describing the whole population, but that's never good enough in any measurement, outside of statistics or not. We need to have a reliability. We need to know what is the error on that. In the statistical language, we just call the error margin of error altogether. And sometimes it can be a lot. Well, that's the complete write-up. Once again, this doesn't make a good MyLab exercise or exam problem or quiz problem. This was just our way of looking into population sample, statistic, and parameter one more time, and just to give a big overview of what's going on in statistics when we talk about making inferences about a population. It has to go beyond that step and capture an error bound as well. Well, the other big thing that goes on is how did they get the sample? I noticed that's misspelled just now. We were told the sample is representative, but lots of things can go wrong just at that step. So even if we had the margin of error put in here, if the sample wasn't representative, everything is just completely ruined and the conclusion's bad one more time, once again. So that's what we're going to take a look into next, sampling designs, how we get representative samples in the very first place. But any last questions at all, folks, before we turn to the next concept? Okay, here is the next concept we're going to take a look into. We're going to look into representative samples and sampling bias. Then after that, we'll look into sampling methods, the simple random sampling being the gold standard method of sampling designs, and other types of sampling methods, some of which are good, some of which are very terrible and should be avoided. But right now we're focusing on just the definition itself of what do we even mean the moment we say a representative sample in the first place? We were told in the last problem we had a representative sample of San Fernando Valley residents. What that means is that sample, which relevant characteristics of the sample members are generally the same as those of the population. So we were saying those 100 San Fernando Valley residents, or they have characteristics about them that really represents everybody in San Fernando. We didn't just take 100 people from just say one region, one county. We have people that represents people all over San Fernando. So that's what representative sample would mean. Thinking maybe in terms of, say, a population like all ISU students, we would have a representative sample of 100 ISU students if some students are on the Pocatello main campus, some students are on satellite campuses like the one in Idaho Falls, that's where I'm at, or Twin Falls or Meridian. Some students would have to be fully online students, maybe not tied to any campus whatsoever, possibly some of us here today. Some students might be out of state and online students and so on. If we take a sample of 100 ISU students and they're all on the Pocatello main campus, it's not representative any longer because the population of all ISU students is extremely broad, in fact. So that's what's being meant when we say representative sample. It has to represent characteristics of the underlying population as a total. And when we say bias, we're going to say the statistical study suffers from bias if its design or conduct, how they actually collected the data or surveyed the people, tends to favor certain results. That's our textbook's verbatim definition for bias. But bias could come in a lot of different ways. Favoring certain results could be just because the population is all ISU students, and maybe we sampled 100 students in Twin Falls. That's a really specific student group, and that's going to favor certain results if we bias it by just taking a non-representative sample in that kind of way. Or if it's a survey question and we just say it's the survey question in a weird way that kind of pushes people into a certain result. Do you agree that, say, people should not drink any alcohol because of these statistics that I happen to know about alcohol? If you write a survey question like that, that's completely inappropriate. If you're just trying to assess people's views on alcohol, you can't give them a spiel on how bad you think it is. Then you're favoring certain results and you're swinging the survey to just match your own opinion at that point. So there's lots of things we can talk about with representative samples and biases. We'll be looking into them a lot more in 5B, should you believe a statistical study. So this is really just our first look into these two topics. Well, we'll study them under the context of example 4, which has 4 different kinds of sampling designs. Any questions about the 2 definitions at the moment? Okay, so here's the context of a study. Imagine you're possibly, say, a student that's doing a capstone project, a research project, and you want to determine the average daily dietary sodium intake of all adults living in Idaho. How much sodium does the Idahoan take on average per day? That's a really big study, but if you're going to engage on this study, you must have a representative sample of Idahoans. If it's not representative, we could accidentally insert bias once we get the random sample. And when you calculate the average daily sodium intake, that number can't be trusted any longer if any bias enters into the problem. So we have 4 different sampling designs. We're being asked, which sample is most likely to be representative? We want a sample of size 450 adults. It turns out they're all of the same size. So for each other sample, explain why that sample is not likely to be representative of all Idahoans. Okay, so this is the problem so far. Let's just write into this, as we're thinking about it. The population is all adults living in Idaho, or all adult Idaho residents, I guess you could say differently. Let's think about these. The first sample is 450 adults to visit a specific hospital's emergency room on Monday morning. That's oddly specific. Sample 2 is a random selection of 450 adults who choose to mail in a health questionnaire included in an issue of a local fitness magazine. That's interesting and highly specific as well. Sample 3 is a set of 450 adults randomly selected from a comprehensive state census list of all adult residents. And finally, sample 4 is a set of 450 adults randomly selected from a registry of all adults for city workers in Boise. You know, the 2 words that I really liked that goes along well with a random sample, or excuse me, a representative sample, is where it said randomly selected. And there's different ways to get a randomly selected sample, but that at least gives us some confidence that we're really getting something that's representative. Let's take a step back and look at these. We want to know which is most likely to be representative. Any volunteers for an assessment on which is the best, most representative sample?
Would it be the third sample?
Yeah, I would agree with that. Notice that the third sample, it is a random sample, much like sample 4, but where are we sampling from? It's sampling from all adult Idaho residents, and that matches up with the population as well. Yeah, I agree as well, Echo. It's going to be sample 3. So if the population's represented there, and we're randomly selecting people from that population, it's from a comprehensive state census list. That has its own problems. The census has to be assumed to be 100% accurate when done, and it's only done every 10 years. Assuming nothing goes too sideways on that, it looks like this one's going to have the highest chance of being representative. So we can write here, sample 3 is representative. Since it is a random sample from the population. So again, when it said all Idaho residents, adult Idaho residents, we matched up the population. And yeah, I agree with what you said there, Echo. Sample 4 is biased. It's randomly selected, but it's from all adults not just adults in Boise, they're city workers. Maybe that was just an easy way to get a sample. Maybe the person conducting the study is based in Boise. Maybe they work for the city themselves. Maybe they're HR for the city workers in Boise. And so they could do that random selection pretty fast. But I agree, this is biased because city workers in Boise do not reflect all adult Idahoans. That is a humongously broad population. Boise is a metropolitan area, and Idaho has humongous areas consisting of some of the rural, what's the way to pronounce that? In Idaho, you're going to find some of the most rural areas in the entire state, in the entire country. These are people who are very different in their habits, mentalities, and diets than city workers in Boise. So we can say sample 4. We want to say why it's not represented, and it is 4 is not representative because city workers specifically is a problem right there. When we say all adults, we include people who are possibly retired, right? That's part of this study at the same time when we say all adults. Again, that's an extremely broad term. So we can complain in a lot of ways. City workers means they're working. We're excluding retirement age people. But I think the bigger thing is, once again, we're restricting to Boise. It's not representative because it does not include people in other areas in Idaho. So if we based our study off this sample right here, well, we're going to have a really bad time with our conclusion. We'd have to revise. Our population is now just city workers in Boise. That wasn't the intent of the study whatsoever. We're trying to study all adults living in Idaho, not just this really fine slice. That's a very small subpopulation. Well, what about samples 1 and 2? Anyone see any problems with either of these? Well, maybe focusing on sample 2, it is a random selection. So again, that word is kind of nice to see there. And it's not restricted geographically to say just Boise, just being city workers. It's 450 adults who choose to mail in a health questionnaire. You probably had to mail out more than 450 before you got to the 450 responses. That's a problem already. These people have a really strong opinion. They were motivated enough to get back to you and mail back the questionnaire. But even worse, this questionnaire was included in an issue of a local fitness magazine. That says something about these 450 adults. They are possibly fitness enthusiasts, and that's going to affect their diet more likely than not. I think a lot of fitness enthusiasts tend to eat just, say, plain chicken breast, very low sodium meals. So here we can say the sample likely includes only fitness enthusiasts because they subscribed to a fitness magazine. And have different dietary habits compared to the typical Idahoan. So that's a really bad sample, I would say. I would say sample 2 is worse than sample 4 because we are really looking into people with a certain set of habits already, which aligns with their dietary habits when they become fitness enthusiasts in the first place. Then sample 1, 450 adults to visit a specific hospital's emergency room on a Monday morning. Again, it's really oddly specific. One specific hospital, they're in the ER, but only on Monday. You know what? This one sounds like it's a convenient sample. It sounds like the person conducting the study didn't know how to get the 450 adults, so they thought, well, I know of this one hospital, maybe it's in Boise, and it's really busy, and I can just ask people when they are maybe leaving the ER what their sodium intake is on a daily basis. Again, that's possibly going to be really hard data to get accurate responses on. That's also super problematic because we're talking about people in an ER situation. These are people who are likely potentially not healthy in the very first place. It can't possibly represent all Idahoans. So what we might say on this one is there's a lot of different things you could say here. It's too specific. Geographically, this is one hospital. It's not talking about all Idahoans. Well, I'll focus on the emergency room aspect. You could write different things. There's a lot of different correct answers to these questions here. I'll say briefly on this one, these are people who are unwell enough to visit an ER, and so their dietary habits does not coincide with the habits of all Idahoans. Or we could say it in the way we did below when we said the typical Idahoan. Well, it's kind of a weird problem. You're going to see one that's just like this in my lab, where you're going to have 4 random samples in some different kind of scenario, and you have to judge which one is the most representative. And you'll use multiple choice or pull down tabs to explain why the other ones are not representative, what goes wrong in the other ones. What we'll take a look into next when we come back on Thursday's class tomorrow is different sampling designs and look at the dichotomy of getting data from an experiment versus an observational study. After we do that, we'll look more closely at biases, things that can go wrong. Unit 5B, should you trust a statistical study? Kind of a inflammatory title the author decided to go with on that one. But any last thoughts or questions, folks, before we call it a night today? Okay, well, have a great evening, folks. We'll be back to it next time.